calm before the storm. Toru, what's going on? Justice, long time no see.
Hello.
How's it going, people?
Well, not much, I guess.
How's that test coming?
I just finished it, but I think I might have to look over it again. Just
Not a
make-
bad idea. Never a bad idea. See, that's the thing. When I was undergrad, I always prayed to not have an in-person test. Or sorry, not have a take-home test, because my theory was that an in-person test, like, look, it's only 2 hours, like an hour. Like, they can only make it so hard, right? I can study or whatever, and then I'm in and out in an hour. That's done. Take home, all of a sudden it's like what if they ask me something really hard, and now it's like I have no excuse not to get it right because I can look it up and teach myself or do whatever. I much preferred take home, but I think actually every single take home test I had was like actually kind of delightful. So I hope your guys is somewhere in between that. But anyway, I'm trying to reorganize my freaking pencil mug here. It's too full, but I'm just so emotionally attached to each one of these. Like, how do you get rid of one? Like, how do I get rid of this guy? Look at this highlighter. Never used it, but I might. Anyway, I'm sure you guys understand that struggle. Welcome back, Safa. Welcome back. Welcome back. Any exciting news to report?
Your exam is my last exam for the week.
How many exams did you have this week?
Just, I think like 3.
Oh,
But yeah.
okay. I guess it's because the drop date's coming up as part of it.
Yeah.
But actually, when is that drop date? That's important.
October 5th, I think.
Okay, you heard it here first, folks. Drop date is October 5th.
It's a Monday.
Monday?
Yeah.
Cool. Or not cool. I mean, kind of cool. I know. It is what it is. It's information, and information's cool. But anyway, so drop date's October 5th for everyone needs to know. So keep track of your grade. Talk to me if you need to. I'm talking to U5 and also U4 and also everyone in the recording right now. Yeah, no, come talk to me if you need to, if you want to talk about things, but do what's best for you. So anyway, though, what's best for me is to stick to what I know, and that is some discrete math. So let's get into it. I might know other things, but as far as you guys know, it's just discrete math, going to keep it that way. By the way, we're trying this setup again, so we'll see how it works. But so last Friday, I was like, hey, we're doing proofs for the first time. It's going to be great. And then Monday, I was like, hey, we're in proofs. Let's talk about all this crap first. And then on Tuesday, I was like, hey, we're still doing proofs. Let's talk about all this first. We've only done like 3 or 4 proofs. Now we're just in the mode of let's start proving things. Let's start building out some practice and start having some fun. So I believe last time, so we're still in section, so now I'd say we're solidly at section 4.2. And last time we did section 4.2, I think the last thing we proved was this claim. We proved Z is not closed under division. Right? And we showed that with the counterexample. We showed like, hey, you take 1, for example, that's an integer. You take 3, that's an integer. 1 divided by 3 is not an integer. It's a rational number, but it's not an integer. Therefore, the integer is not closed under division. Totally good there. Here's the question. Let's see here. So next claim. Q is closed under division. And Q represents all of the rational numbers. So first off, let's go ahead and write down what the heck this even means, right? Because English is great, but logic is better. So let's write this formally. So formally, saying that the irrationals are closed under division, is this a existential statement or a universal statement?
Universal?
Still universal, yeah.
Universal, right? Because we're making a claim about really all the rational numbers. And what we're saying is that for all A in the rational numbers and for all B in the rational numbers, A divided by B is in the rational numbers. That's what it means to be closed. It means you can do this operation with any two things in the rational numbers and you'll get another rational number out. So the first step whenever proving something is to figure out, is it even true? Should I be proving or disproving this, right? So let's do our side, which I've done in green for some reason, but I like it now, so we're sticking to it forever. And that is true or false? What do you guys think?
It has to be true, right?
It looks like it, right? Let's do some examples, right? So give me a rational number.
5.2
Okay,
or
yeah.
something.
5.2. Anything else? Who's got another one? Just to prove that this isn't me, this is you guys. There's no way I could have known we would have had 5.2. What's the second number?
Pi?
Pi? So pi is a great number, but it's actually not a rational number. So
Okay, interesting.
numbers, yeah, it's irrational, right? So actually, that's a good point, though. Let's just remind ourselves. Recall that Q, I'll say the rationals is Q. We don't want 3 bars. 3 bars means logically equivalent. I'm just saying these sets are equal, meaning they're the same thing. They have the same elements. The rationals, we represent like that. And it's literally just all things that take the form A divided by B, such that A is in Z, and B is in Z, and B does not equal 0. I don't know if you can see that. So that is what the rationals are by definition. And by the way, any clue why we call them the rationals?
Because we could take the ratio of them.
Exactly. Nailed it. Because of the word ratio. It comes from that, because we're literally taking a ratio of A to B. Also, it sounds like the rationals, it sounds like a, what's that group where they do the really high leg kicks in New York City? And the dance troupe where they hold, whatever. It sounds like some sort of old-timey 50s dance troupe to me. The Rationals. We're gonna go see the Rationals at the Radisson. But anyway, so the point is, that's what the rationals are. And so 5.2 is one. Who's got another rational for me?
1.1.
1.1. These are good rationals, right? By the way, the rationals, they turn out to be all numbers with terminating or repeating decimals. So that's how you can tell. That's how I know that this is a rational number, because it terminates. But also, like the number 3.745, 745, 745, 745, dot, dot, dot. That's also going to be rational because it repeats. Irrational is where you have infinitely many decimals and does not repeat. Turns out that's equivalent to being able to be written as a ratio of integers or not. But anyway, yeah, 5.2 over 0.1. What's this? It's going to be 5 plus 2/10 over 1/10, which is 52/10 over 1/10. Flip and multiply. This is going to be 52 over 10 times 10 over 1. Cancels. 52 over 1 52, which is in fact in the rational. So it works there. And let's start to think about why this will work. So let's think about it, right? If you take any a over b, because this is irrational. Or let's take like x over y, right? Where x is irrational, y is irrational. Then you have a over b divided by c over d. I'm calling x equal to a over b. This is really informal. It's our scratch work. I'm calling x equal to a over b, y equal to c over d, right? Where all these got to be integers. So it's got to work out. And then we can always flip and multiply, right? So this becomes a over b times d over c, which is going to equal AD over BC. Is AD over BC going to be a rational number?
I actually have a question here then.
Yeah.
What's inherently stopping you from y being 0? Because is that not rational still? Like, I understand it makes it an impossible number, but that's
Nothing.
like nothing.
Toru, you're right. Why? You're right. 0 is a rational number, right? Because 0,
Right.
0 equals 0 over 1, for example. So so it fits the definition of being an a over b, right? Where a is an integer and b is an integer, because 0 and 1 are in fact integers. So, I mean, this totally fits. So 0 is in the rationals. So it's perfectly fine to ask the question, okay, well then, what about 1 over 0?
Right.
17 over 0. What about 3.14? But you don't, you just that. You stop it there. Approximation for pi. 3.14 over 0. These are all undefined, meaning they're not defined to be an integer or to be a rational number. Excellent call, Toru. So the point is, the rationals are not closed. Q is not closed under division because of 0. Right? Does that feel like cheating? This feels satisfying, doesn't it? It feels like, oh, okay, there's that one case. But it's important, right? This one case can ruin everything. 0 is a perfectly fine rational number. It doesn't work. And so it's important to think about that kind of stuff. And you absolutely nailed it. Good job, Toru. And by the way, this whole thing is undefined. Undefined, you know what undefined means? Does it mean don't talk about it, move on?
Is it irrational?
No, not irrational. That's a good point. It's not rational. But being irrational means a little more than not being rational. It means you're real, but not rational. But anyway, if you divide by 0, and literally undefined literally means undefined. Like, all of these things have definitions. Like, division has a definition. Like, A divided by B equals the C such that A equals CB. Like, that's the definition. We call A divided by B, we call it the number C, where C is the unique number where A equals CB. The problem is, if A is not 0 and B is 0, the problem is, well, you can't get a C. There is no C, for which case A would equal C times 0, if A is not 0. If A is 0, the problem is we're going to have infinitely many C's where it works, so which one do you pick? And so the point is, they're both, whenever you divide by 0, it's undefined. That literally just means we don't have a definition for it. It's not, like, you can make one up if you want to, but we don't have a solid, consistent one, so we're just going to leave it undefined. The point is not anything special, it's just literally undefined. So it's just kind of like a hole in math a little bit there, a hole in division. So the point is, we just prove this.
Is that similar to the square root of a -1?
It's exactly like that. Exactly like that. In the square root of -1, we could have called it undefined, and people did for a while. But someone was like, hey, call that I. It will work from there. And boom, complex numbers come from there. It's called a field extension. It's a whole thing. It's interesting. But anyway, yeah, it's exactly like that. It's also the same thing as, like, before you had negative numbers, what's 1 minus 2? Right? Before you had negative numbers, you could call it undefined. But anyway, so we want to be disproving this, right? Because of 0. So to disprove a universal, what do we need?
Negation. Oh, well, you need a existential statement.
Yeah, you're proving,
Yeah.
we're really proving the existential statement. We're proving the negation of this, which is that there exists an A in Q, such that there exists a B in Q, such that A over B not in Q. That's what we're proving. But I was just gonna say find a counterexample, right? But that's what it means to find a. The counterexample means you're finding an example where this works. So we're proving the essential statement. That's fine. But yeah, so find a counterexample. So let's say, so we're gonna prove by counterexample. Let's go ahead and let A equal, I'm just gonna pick, you can use any integer, right? Because whatever integer you divide by 0 is not gonna be good. I'm gonna use 7 for some reason. Let A equal 7. And let B equal 0. Or let's do like 7.2. Something like that. It's not weird. Note A. Actually, sorry. Just to make it a little simpler, let's do 7/2. Something like that. There we go. So A 7/2 and B is 0. Note A equals 7/2. And 7 notes. What do I want to say? Since 7 is in Z and 2 is in Z, A, oh, this is where we have to be so careful. So I'm trying to prove that A is a rational number, right? So since 7 is an integer and 2 is an integer, and last time I checked, 2 does not equal 0, 7 over A, which equals 7 over 2, is in Q by definition of Q. Whew, exhausting. That's the point. That's why 7/2 is in Q. Further, now we need to show that 0 is in Q. So further note 0 is in Z and 1 is in Z. So 0, which equals 0 over 1, is in Z, or in Q, by the definition of Q. So this is proving beyond any doubt 7/2 is a rational number and 0 is a rational number. We're just writing it out. It's obvious but important. So once we have that, then A over B equals 7/2 over 0 by substitution. Which equals undefined. Not unrefined, but undefined. It's very refined. Wait, yes. So which equals undefined. Thus, A over B, which equals 7/2, is not in Q. Because something is undefined can't be a defined thing like a rational number. So A over B of 7/2 is not in Q. Therefore, there is an A and B and Q. Oh, you guys can see that. I'm sorry. Therefore, there is an A and B and Q such that A over B is not in Q. So claim is false. Boom. Whew. Any questions? I think that is the only good, that is the one benefit of all this excruciating detail, is the fact there should be no questions. It is all here. It is all laid out, everything. We even proved 0 is a rational number. Probably never thought you'd see that, but there it is. Any questions? Yeah, that is just that. So that's how you disprove something, right? We found a counterexample, but we go through it very logically, right? You always have to show. You always have to show you're doing a counterexample that the thing that's your counterexample actually fits what you're looking at, or actually fits what you care about. What I mean here is you're trying to find a counterexample to the idea that any two integers or any two rational numbers when divided will be rational. So we found two rational numbers, 7/2 and 0. And the first thing we have to do always is what we do here. Show the example satisfies domain. So we're showing that these are actually, in fact, in the rationals. Okay, let's move it on.